Mega. Yeah, Mega helped. Hmm? Hmm.
Good morning, everyone. Welcome on the second day of our Gyan course. Today we are going to start with DID, and Professor will start.
Meghna, I'll come to your lab around 4:30. जो जो डेटा है आपको भेजा था बाद में भी IPD बोल के एक है ना वो सब लेकर आना because we have to merge it properly. Last time your margin was not correct. Okay. So note, we are going to start with DID, and basic thing is from Ulrich, Introductory Econometrics. And then there is a paper by Woolden and Moen, the triple difference estimator, which is basically, a lot of people call it DIDID, because that is like triple differencing. And the paper references Econometrics Journal. I have no idea whether you have access to that journal over here, but at the end of the day, I'll give you the paper which I have downloaded. Clear? Fine. So basically, it's a combination of the two with Introductory Econometrics by Ulrich, and then the paper by Olden and Moen in terms of triple difference estimators. Yeah? Shall we start? Okay. And I'm going to give you some examples of regression discontinuity without actual data, but with some simulated data. So instead of simulated data, you can, whenever if you need it to use it in that kind of particular framework, you can replace it with your actual data set. Clear? Fine. So given this, the way I'm going to start again, I'm going to talk more about counterfactuals, then the causality, and then the last part would be the policy. That's the part which I don't know anything about it. But there are a lot of economists over here who can suggest policy. Then I'm going to talk about constant treatment effect, and I'm going to talk the problem with the constant treatment effect. Then I'm going to introduce you difference in difference estimators and the assumption, main assumption behind difference in difference estimator, which we call as the assumption of parallel trends. And it's quite important to test for the presence of parallel trend before and after the event. And then last, I'm going to focus more on the triple difference estimator, and I'm going to hopefully at the end of the day show you triple difference estimator is nothing but another way of doing DD, or the double difference estimator. And then finally, I'm going to touch upon regression discontinuity, which is another way of looking at the program evaluation literature. Okay. So note, I'm going to start again with very simple exposition. Now think of I don't have any continuous variable in my model. I could have, but suppose I don't have. So the way I want to think about it, X is nothing but my policy variable. Okay? I could have lot of controls, but for simple exposition, I do not have them. You can have like plus summation of I 1 to k beta I xk for that, or xi for that matter. So note, whether you have it or not, my focus or our focus is on x. And x is nothing but a binary. So when the event kicks in, it takes the value of 1. When the event is not there, or you are not being exposed to that event, the variable takes the value of 0. Yeah. If I take the expectation, assuming that expectation of u is equal to 0, then my expectation of y can take two different values. Under when the program is in operation, it would take the value of beta 0 because simply x is equal to 0. And then in the other case, when x takes the value of 1, it would take the value of beta 0 plus beta 1. So the incremental effect is nothing but being captured by beta 1. So if I run a regression which allows me nothing but, if I don't have any other control variables in the regression, all I am going to do is basically evaluate two means, right? The first mean is my expected value of y given x is equal to 0, and the second mean, again conditional, on x is equal to 1. I take the difference between the two mean and I call that's nothing but can be attributed to the program. So my difference in the mean, which is my beta 1 in my framework or in our framework, is nothing but estimates the impact that is coming from when the program is in operation. Very simple, right? So that's how we start.
So can you please repeat once again?
Yeah, sure.
In process.
Sorry.
You mentioned about that the one is the training program is in process.
Yes.
One is before training.
Yes.
After training.
Right. So suppose when the training was not in process, then x takes the value of 0. When the training is in process, then x takes the value of 1. I want to know your expected productivity when you do not have any training and when you do have training. When you do have training, that's my beta 0 plus beta 1. When you do not have training, then it's beta 0. So the difference between the two is nothing but can be attributed to those guys who went through the training. Clear? Fine. That's what all I want to tell. So given that, I then want to think of that my treatment, or in my treatment kind of model, my treatment which I measure by chow I is nothing but the two different values that the y can take. One value is y takes the value under the assumption of 1, like my binary, and then the other would be y is equal to 0. But the problem is that unless you are living in the paradigm of the movie Sholay, where Amitabh used to have a bias coin, in both cases, in both sides, what happens? There was head, right? So that's an impossible way. But what is more like a possibility, we don't observe both y1 or y0 at the same time. Because if head occurs, then tail never can occur. Or if tail occurs, head never can occur. So either head occurs or tail occurs. So whether the event takes place or the event doesn't take place. Job training occurs, job training does not occur. But you cannot have a situation where the job training occurs and it does not occur, right? So then that's the way we want to think of, that we either observe yi1 or we observe yi0, but not both at the same point of time. And hence, I can define my average treatment effect is nothing but tau ATE. So that's why I'm using the notation, is nothing but expected value of the difference, yi1 minus yi0. Clear? I then want to take this sum over all the i's, divide it by the number of observation, and that's nothing but my expression in terms of those expected difference between yi1 and yi0. Clear? So note what I can then think of, y0 and y1 are nothing but two random variables. What are they represent? They represent the counterfactual outcome in the population, right? Why it is counterfactual? As I explained, nothing can occur or they cannot occur at the same point of time. So the way I want to then think about it, later on in the course I'll talk about it, that how to create the counterfactual. That's going to be also very important. So if I do not have any exogenous policy in that way, can I create a counterfactuals? And creation of counterfactuals goes into the domain of what we call as propensity score matching. Clear? So the basic difference between I need to ensure that this policy is completely exogenous, right? Okay. And then if the policy is endogenous, how can I control for endogeneity in the policy? Like the self-selected people can get enrolled in a job training program, and some people may not get enrolled in a job training program. I leave that to individual choice, or the employer leave it to individual choice, and hence there could be a problem in terms of selectivity bias. Clear? So then given that, I want to handle the situation later on, but there could be something like I do not know it. However, I still want to create the counterfactuals. And one of the way I want to show you creation of counterfactuals is nothing but belongs to the domain of propensity score. That's what I understand so far in terms of DID. Yes.
This Y1, that is an observation when the policy has kicked in.
Yes.
So how can that be encountered?
Because I'm trying to think of that there is no absence of policy, presence of policy. So Y0 you can think of the tail of the coin, and Y1 you can think of head of the coin. So Y1 occurs, Y0 doesn't occur. So some people got exposed, some people doesn't get exposed. That's the way I want to think about it. So the counterfactual is nothing but the opposite side of what has happened, right? And the entire thing would depend on creation of the counterfactuals.
What do you mean by what is counterfactual?
What do I mean? Okay. The way I think about it, COVID vaccination was distributed as part of the government in India, right? Now, if you are elder, you would get access to the vaccination before someone else. Even if you are not elder, but if you are an emergency worker, you will get access, right? Now, suppose think of it, I make a fake ID of being an emergency worker, right? So I will also get exposed. So I am not an emergency worker. However, I got the vaccination before you do. And then suppose Priti belongs to the true emergency worker, and she gets the vaccination by something like in terms of her eligibility to get the vaccine. Now think of there are three people then. One true, one doesn't get it, one got it by creating fake ID. So in case of, if I want to think of the impact of COVID on future occurrences, I need to compare the three of them, right? People who are really emergency worker got exposed to different kind of COVID, right? Or COVID patient that way. People who are making the fake ID did not get exposed to any one of those COVID patients, my counterfactuals. They did not COVID, but still they got the vaccine. Clear? And then there are this set of people who doesn't get anything because they are not eligible enough to get the vaccine when the vaccine rolling out has started. Clear? I'll come to that a little more. So note, counterfactuals outcome, causality, and I want to think of some of the policies. Yes, please.
So the beta 1 in the first slide
Yes.
same as the average treatment effect.
Yeah.
The beta 1 here is same as the
Yeah,
average.
yeah. So note what I want to do. Each unit Xi, let be the program participation status. So that's nothing but a binary. And the observed outcome is Yi. So then I can write the Yi as nothing but a convex combination. Convex combination of what? Of Yi0 and Yi1. So how do I write it? In one side, I will have 1 minus Xi when Yi takes the value of 0. And then in the other side, I will have Xi when Yi takes the value of 1. So think of a concave curve, right? So there are these 2 points on the concave curve. I draw the line and the curve is concave because the line inscribed by the curve. I can then take the midpoint, and midpoint or something like that has the equal weight on both sides, half and half. I may take a weight of Wi and 1 minus Wi, and I can start varying Wi. I do that exactly over here. 1 minus xi times 1 yi0 plus xi times yi1. Clear? Fine. So think of in this way, where yi takes the value of yi0 if the binary takes the value of 0, and takes the value of 1 if the binary takes the value of 1. If you do some manipulation, then yi can be written as yi0, right, plus xi times yi1 minus yi0. Recall my definition. yi1 minus yi0 is nothing but my treatment effect. Hence, I substitute that by tau. Clear? Fine. Given my equation 2 and my equation 3, then I can write that simply as yi is equal to yi0 plus tau xi. Clear? Fine. Note yi0 then also can be written as a constant, which is alpha 0, plus a random error, which is ui0, where alpha 0 is nothing but the expected value of yi0. Clear? And expected value of ui always is equal to 0 because that's my random error term. Similarly, given this, I then can write yi substituting the value of yi0 as alpha 0 plus ui0. Clear? As alpha 0 plus lambda xi plus ui0, which in terms of regression model, I can express it as yi, which is equal to beta 0 plus beta 1 xi plus ui, where beta 1 is nothing but the causal effect. Is it clear?
So why this tau does not have this subscript of I?
I can vary it because it's a constant treatment effect. If you have a differential treatment effect, of course tau would vary.
But this tau is,
The tau is nothing but yi1 minus yi0.
so this will be for,
So the tau is nothing but here, yi1 minus yi0.
but since this varies across I, right?
Yes,
So this tau,
it may not vary. People, whoever got the treatment, get some kind of increment. So think of this. I mean, I think I forgot which book, maybe Johnston, maybe Gujarati, maybe Madala. There always used to be an example of introducing Chow test in terms of structural break, right? And if I recall, if my memory is correct, in general it doesn't betray me. So that's like a war kind of consumption function and a normal kind of consumption function. The slope could differ, the intercept could differ. Here I am interested more in terms of the intercept. So beta 0 is the intercept when it is normal time. Beta 0 plus beta 1 is the intercept when it is the what time. And in what time I expect beta 1 to be negative. And that's nothing more than that. I'm basically having two parallel lines with a intercept jump. Okay? Clear? And the jump occurs when the program is taking place.
So how does this beta 1 as a causal effect now is different from if I do a simple regression of, let us say, yi on...
Absolutely. It is the simple regression. It is the simple regression of on your outcome on binary and the set of controls. And if you think that the binary is completely exogenous, hence I can attribute that as nothing but the causal effect.
It is the exogeneity of the policy.
Exogeneity of the policy is extremely important. Yeah, exogeneity of the policy is completely important or extremely important. Right?
In that case, I mean, any kind of a policy, suppose, for example, we are talking about any industrial policy, agriculture policy, it evolves from within a system.
Yeah.
So then, how do we establish its exogenity until and unless we are looking at any policy happened in Germany and its impact on, let us say,
Yeah, yeah. So that's like a spillover. That's like a spillover. That something has happened in some other country, whether there is a spillover in India.
so their exogenity is part of the past.
There is.
But in within the nation's context, I think
Then you need to think about why did the policymaker introduce the policy? Is it because of some internal pressure? If it is because of internal pressure, it must be then the policy is endogenous.
So I'll give you one example. So, for example, we talk about TRIPS policy, right?
Yeah.
So TRIPS related changes they came and they were exogenous.
Right.
Because we are doing
Right.
it because of them. Now, but after those changes, suppose we say that we had a transition period in which the TRIPS has to be now implemented, but that was dependent upon your legislation and you have
Sure.
to get it passed.
Sure.
So then the delay in the application of each part of the TRIPS, it cannot be treated as exogenous.
No, it cannot be. So the policy itself is exogenous, but the implementation of the policy is endogenous. And that's what happens. Food for Work program, when the policy got started, it started as an exogenous event, but the implementation of it could turn out to be endogenous. I don't know. I mean, I'm just like midday meal program. I mean, very few people perhaps in this room know that the midday meal program is actually being introduced in Tamil Nadu in 1959. Lot before than people talk about the midday meal program. Okay, so that's the way we need to think about it. So in that way, Tamil Nadu, if you think of the later on investigating, you may need to go back to the history and look at which are the villages which already had the midday meal program from 1959 onwards, and there could be new villages which got involved because of the complete policy change by the GOI in case of all states in India.
Are there any parameters based on which we can establish the exogenity? These are the
Difficult. So a lot of times what people do, they use a lot of other controls with the assumption that those controls would perhaps determine or would somehow think of them that if I can have those control, the control would control for the endogeneity or in that way treat the policy as exogenous. Clear? Fine. Shall I move? Sure.
Where is the yi naught is equal to alpha naught plus y?
Huh?
Yi naught is equal to alpha naught plus y naught. That
Yeah.
is just by
Assumption.
just an assumption.
Yeah, because alpha naught is the constant. And anything observable have a deterministic part and a stochastic part. And the stochastic part is EY0. Clear? Fine. Fine. So where are we? Recall where are we? Yi is equal to beta 0 plus beta 1 xi plus ui. So I started from there where beta 1 is the causal or the treatment effect. Now what we want to do, we can find out whether the simple regression estimator, as I was telling you, that now the difference in difference estimator is unbiased for the treatment effect or not, right? And the unbiasedness would completely depend on what Ruchi was trying to tell in a different way, that whether xi is independent of ui, right? So the way I want to think of that's nothing but my zero conditional mean assumption, expected value of ui 0 conditional on xi is equal to 0, right? But when can I guarantee that is bound to happen? It is bound to happen if and only if the assignment is random. So I flip the coin, all of you are here, I make 5 groups, I say this side this, if head happens now. Again I flip the coin, and if tail happen, I say this side belongs to this. Now again I flip the coin, if head happens, I say this middle belongs to this. So it's like completely random, because when I'm tossing the coin, then I don't know whether the head or the tail will appear, right? So I call 100 workers in one fine day, keep on generating some random numbers, and I gave them those random number, and then I say these are your number. You go and pick one of those number from the on, and if you pick the number with a red color one, then you will get the training, and if you pick the one with green color one, you don't get the training. It's a random assignment. And the random assignment would ensure that the zero conditional mean assumption is valid. So this assumption can be guaranteed only under random assignment. Clear? Where units are assigned to the treatment and control group is basically using a randomization mechanism. And by randomization mechanism, I don't know the feature of Kiran, or for that matter, I don't know the features of Meghna. I don't know. I'm something like, now something like this PC Sharkar, who has the blind eyes and then cutting the human being in a magic show. Clear? Fine? That's how it is. Clear?
So generally we don't have random assignment.
Generally we don't have, and that's the problem. Clear? So note Hariam's point, constant treatment effect. The constant treatment effect is nothing but simple diff and diff estimator. Take the mean exposed, subtract the mean of those guys who is not exposed, and nothing but the difference is constant treatment. Clear? Okay. Now, if I now think of, can I relax this assumption at least of the constant treatment? I can, of course. So I want to then move from the constant treatment to the individual treatment effect, right? So the way I want to think of that, the total treatment effect, which is TEI, see it has a subscript of I now, which is YI1, see now has a subscript of I, YI0, where YI1 is nothing but alpha 1 plus UI1. Clear? So TEI then YI1 minus YI0 as it is, which implies that's lambda ATE plus UI1 minus UI0, where lambda ATE again is nothing but equal to those difference like alpha 1 minus alpha 0. So how do I estimate this? The average across the entire population, okay, my lambda ATE, and the difference UI1 and UI0 is nothing but the deviation from the population average for a particular unit, which is nothing but my I in this case. Clear? Can I get some water, please? Okay. So given this, note my equation 2. We started over there, right? Shall I go back a little bit more? That's my equation 2. You should have the PowerPoint slides with you, right? Thank you. You should have the PowerPoint slides. Anyway, so let's start with the thank you. So let's start with equation 2. So given this equation 2, I just write the equation 2, nothing more than that. Okay? Whatever you have already. Now, TEI I define as YI1 minus YI0. I substitute the values. So TEI then nothing but going to be tau ATE plus UI1 minus UI0. Call it my, that is equation 4. I now use equation 2 and 4, get nothing but my equation 5. Clear? So note, how do I think of my equation 5? My equation 5, the way to think about it, has alpha 0 plus tau ATE xi plus ui. What is my ui now? Ui going to be ui0, that part over here, this ui0, plus nothing but ui1 minus ui0 times my xi. What does the random assignment to do? Note, if I take the expectation of this guy, so that would be expectation of this guy conditional on xi, plus expectation of this entire term times xi. Now, expectation of this guy is equal to 0. expectation of this entire thing is 0. So then I get it 0. So therefore, the simple OLS estimator is unbiased for both the alpha 0 and tau 80 E, but this is based on, again, the assumption of random assignment. Clear? It's a very simple proof. Then we will later will come to the fact when the regression analysis we can use when the pure random assignment does not hold. Clear? Given this, what do I mean by random assignment? Yes.
So even when treatment effect is not constant, we see that
We can do that, but under the assumption of random assignment. So note so far what we have done. What we have tried to do, that how important is random assignment. In medicine, in biology, doing this randomized control is quite easy because it's a lab based, right? You pick 50 guinea pigs, you give some of them high dose of cholesterol, you don't give them some of them the high dose of cholesterol. You observe them after 6 weeks, what is their impact of the high dose of new medicine cholesterol on them, on their cholesterol level. Very easy to do. But in practice, it is, in terms of our field or social science, it is not that easy to conduct RCTs, right? So given that, I then want to think about it, that what kind of experiment, and that's what one of the way the experimental economics or the behavioral economics started, because they also conduct something like completely lab-based experiment. Okay, so that's the way it started. That how would I run an experiment where the random assignment is a possibility? Clear? Fine. And that's the entire way the experimental economics or the behavioral economics starting point was. So note, what are the trade-offs then we have, right? We have the trade-off that we can think of, that I use a regression model, like Professor Kiran used the regression model more for prediction purpose, not for causality, okay? Because in finance, prediction matters, right? The way I can think about it, I can then have something like this risk versus return trade-off in my frontier. So what is the trade-off? I have prediction, I have causality, right? And one way to think of that, I'm going to measure trades off on one variable for the other, y versus w, the risk versus the return, the variance of x versus the mean of x, right? Clear? So that's the way I want to think about it. Let's think of that y is the annual salary of anybody who is working. And let's think of W is a measure of VRS. In India, in bank, a lot of times or sometime back, the VRS compensation has happened, right? A lot of people took it. Then again, the government changed the rule, and then you can apply again by giving up some money for the pension, okay? So let's think of Y is the salary and W is the measure of VRS compensation. Now, if I and you are indifferent between the two policies that is being, or the trade-off that is being faced by us, then what I can think of, that 1 unit increase in VRS could be associated with 1 unit decrease in my salary. So that's my equal trade-off, right? So given that, total compensation would matter, assuming all other relevant factors, whatever it is, they are kept as constant. I'm just going to look at the total compensation, because I know 1 plus should be accompanied by 1 minus. So because it's a zero-sum game at the end of the day. Clear? So given this, we would expect, what should you expect? A positive correlation between salary and VRS benefit. Why? The VRS benefits are always tied up to the salary. If your basic is 30,000, your VRS would be different than your basic is 60,000. Clear? So more your salary, more your VRS benefit, a positive correlation between the two. And then what we want to know, for a given individual, how does he or she trade off the one which is the salary for the other which is the VRS compensation? Is it clear? Fine. For an investor standpoint, how do you trade off between risk and return? So one way to think about it, when you are 25, you invest in mutual funds where everything is equity. But when you are 60, then you start investing in a, or maybe 55, in a balanced portfolio. And when you are 60, you put the money in your debt fund, because debt fund at least ensure 8 to 10% of return. That should be correct, right? Right? Whereas on the other hand, equity can give you 30% at one point of time. Right?
Right.
Clear?
Yes.
Good. And you are making the trade-off. Note, the way then we want to proceed is in terms of gender difference in their wage. So what is our interest? Our interest is nothing but whether gender discrimination exists in the labor market. How would I do it? I basically observe the wage. I have a binary for male and female, and I have several controls which determines the wage. Clear? So the way I want to think of that, I can use OLS provided we are able to include all other variables. Remember day one, what we did. If we are not able to include all the relevant variable, we suffer from the omitted variable bias. And the omitted variable bias would lead to biased estimate of OLS. But on the other hand, in reality, it is almost impossible to include all relevant variables which we think that could determine the wage. Right? Again, a trade-off. So given this, so if I now want to think of, that suppose I have a binary policy intervention and I want to use the notation what we did before in terms of counterfactuals. So now let us change the notation a little bit. Let's, instead of xi, use w to denote the policy indicator. Recall we started with x, we just simply change the x to w, because x in our case is the set of other explanatory variables, nothing more than that. So note, for constant treatment effect, we have done it. Now for the varying treatment effect, I am going to calculate what? For the entire population, the expected value. Because note, it has a subscript of yi1 and yi0. For a random draw, I can then think of, again, the convex combination. We have done that. Where what we have done over there, 1 minus xi times yi0 plus xi times yi1. Now note, my xi is being replaced by wi. So everything remains similar. OLS would give unbiased estimate provided w is independent of what? Of both occurrence, y0 and y1. So w shares nothing with y0 and y1. That is the policy. Clear? So given this, if I think of x is the set of controls, w is then independent of y0 and y1, with the assumption that I have condition for x. So from a simple regression model, I am now going to multiple regression model, because I am just thinking of x is the set of control and w is independent of y0 and y1 conditional on x, right? So note, in this DID literature, it is known as the unconfounded assignment, conditional on x, and that's the assumption the DID model thinks about it. Okay, the way to write it is w independent of y0 and y1 conditional on x. Fine? Clear? Shall I move? Yes, please.
So here we are assuming that W is our the wage.
Now, w is our binary indicator.
Binary indicator.
Yes.
Whether a person is a male or person is a female.
Any policy. Any policy. Right? Previously, X was your policy. I just replaced the X by the W. Nothing more than that.
And X is set of control.
X is now set of controls because I am now in a multivariate regression framework.
So this confounding assignment is again kind of parallel trend assumption.
I don't know. I really don't know whether I can treat it like that.
So basically, this the
Possible, I don't know. I really don't know.
so basically the meaning would be the binary assignment would be independent of y naught
And Y0.
Y0.
After I with conditional on the set of the explanatory variable.
What
Yes.
is the confounded assignment conditional on X when this W is not independent of X?
Yes. Yes.
Can you just explain more on what do you mean by W is independent of YO and Y1? YO is before and Y1 is after.
Yes. So policy takes place. Policy does not care about the outcome, whether it is pre or whether it is post. Right? I just introduced this policy.
Like a
Yes.
training program is organized. GAN
Yes.
course is organized.
Yes. Yes.
It's very difficult to say it's independent of what's not happening.
Absolutely. Absolutely.
Want to
So
authorize-
all we want to then think of that it is going to be independent conditional on X because you know the syllabus of the course. That's my explanatory variable. Condition on that, you have taken the decision of participating in the course. And looking at the material, somebody else did not participate in the course. Outcome could be that after that you do a chapter in your thesis or with the DID technique. And whether you are able to do it properly or not, that's my measure. I think that's pretty good example.
Here I always get confused about this. One is this exogenity, and one is this about issue of self-selection.
Yeah.
Right? Many times they kind of brought together. But
Yeah,
two
possible.
separate issues.
There are two separate issues, but they are interlinked because sample selection also gives rise to endogeneity. That's what we did yesterday. Clear? So we did that.
Since we're looking at differences in hourly wage based on gender, then what does W like? Any example of W?
Anything, training program, anything. Think of anything.
So receiving the training program given your gender.
Yes, yes,
Receiving the training program.
yes.
So why?
Irrespective of gender, the training program get introduced. Now you want to think of whether the training has a differential impact in terms of your gender on wages. That's the way to think about it. So I have already control for whether you are a male and female. Now I am having this training program. I want to see the incremental effect of the training program on the gender wage differential. That's what I want to do. So in terms of recruiting people, lot of company give them a stock option, right? So whether you would be able to get the people who are in the market, provided you give them a stock option of 2% or not, versus some company may give you 5%. Look, the treatment is different, 2 versus 5. But some company may not give you any stock option. So that's like zeros. So then you want to combine 0 versus 2 versus 5. Right? And you want to see that who is accepting the offer. Provided you have control for every damn thing in terms of probability of accepting the offer. Yeah? So note that's the assumption. But then the question is, how do we estimate this equation, which is 6? So recall in population, y is equal to y0 plus tau w. and expected value of y given w and x is nothing but expected value of y0 conditional on wx plus tau w. That's clear? Fine. So then assume that expected value of y0 conditional on x is a linear function. Given it's a linear function, I can think of that's nothing but expected value of y0 conditional on x is nothing but alpha plus x times gamma. I substitute that in my previous equation, which is this equation, this term, I get this regression model where I control by x, by including the x, the vector of the controls, which can have a relationship with the expected value of my outcome. Right? This entire thing works with the assumption that expected value of y0 given x is linear in nature. Clear? Fine? Shall I move? Let's open the data set in your computer. So you open Stata, you open BCU's JTrain 98, and then do these two lines. Do it quickly. We have to move fast. Yeah. Of course you have to. No, just open the status. You see that it is written what you have to do. Open Stata. Use JTrain 98. DES is nothing but description of the data set. First, run that regression. Reg R98 on train. So that's like your training example. Then you run the same model, including lot of other explanatory variables. If you think of the slide just before, that's what we are doing. Expected value of y conditional on w and x. W is nothing but training in your case. X is nothing but the other variable which you think can determine the earning of 98. What are those? Earning of 96. Then whether you are married, your education, your age, whether you are black or whether you are Hispanic. Right? In India, you can think of the black and the Hispanic gets replaced by the caste and the tribe. Done? Right?
Just running the last regression.
Yes. Huh? Sorry? What do you mean didn't get? You couldn't download the data? Yeah. So look at the JTrain coefficient in the first regression. What is the coefficient?
So the bivariate regression.
Yes. What is the coefficient? Huh? Minus 2 point? So that means if the people who went for the program is earning less than the people who didn't go for the program. Now look at the next regression. Absolutely. So what is happening? Without those explanatory variable, it's giving you a misleading picture of the impact of the training. what we expect that the training enhances, increases your earning. When you do not have any set of controls, then you get a negative coefficient. When you have included the set of controls, then you start getting a positive coefficient. So basically, this shows how important it is to have a specification like this guy over here rather than just this guy over here. Right? Clear? So instead of just having alpha plus tau w, you should perhaps have a model where you include lot of explanatory variables. Now you understand? Good. Fine. So given this, how do I make it again? Yeah. I'll do it. Don't worry. Okay. The basic thing of the diff in diff started with a paper by Curd and Cougar. The reference is there and the link is there also. So you can download the paper pretty easily. And there was another paper, again by Curd, which I used to teach at one point of time, is basically the paper title was Mariel Boat Lift. So what happens from Haiti, a set of immigrants came to Florida. And given that set of immigrants, what that paper, Mariel Boat Lift, start analyzing what would be the impact on unemployment rate. This Mariel Boat Lift happened between 79 and 81. Right? So I have two time period, pre and the post. But all of them came to Miami. I need to create a counterfactual of Miami, which shares almost the same characteristics as Miami, but not Miami, because where the Mariel Boat Lift did not take place. And what the author did very cleverly, they use Miami shares lot of common characteristics with LA. So they use LA as the counterfactual and use then this event to analyze the impact of the Mariel Boat Lift on unemployment rate in the state of Florida. Yeah, very clever. They include so LA did not have any problem, but Miami had the problem. But you just cannot do Miami with Miami. You need to have the counterfactual. And that's what the counterfactual was, nothing but LA, where the Mariel Boat Lift did not occur.
So a region where they put a
program happens, a region which is very similar in characteristic, the program doesn't. Yeah, whatever it is. Two situations. But then you need to compare it. So think of an example. Think of an example. West Bengal versus Rajasthan. In West Bengal, there was a Borga operation in 1977. Clear?
Is it land reform?
Land reform in 1977, which is known as Borga. Okay? The left came to the power. The first thing they did is the Borga operation. Rajasthan does not have any Borga operation. So I can do a diff in diff between Rajasthan and the West Bengal. The referee would criticize. It's a paper by a friend of mine, Maitresh Ghatok. He's a very nice guy. So Maitresh is at LSE. So what Maitresh then did with his advisor, Abhijit Banerjee, what they did basically, they, instead of Rajasthan, they took Bangladesh as the example. Because why? Bangladesh shares lot more characteristics with West Bengal in terms of the climate, in terms of the kind of vegetation and things like that. Soil, everything, right? Rain. And then the counterfactual was Bangladesh. The counterfactual was not Rajasthan. Think of it, I can now do triple difference. Why? I have West Bengal, Rajasthan and Bangladesh. Right? So I then want to compare West Bengal with Rajasthan, Rajasthan with Bangladesh, and I just take the differences in the means and I come up with the overall contribution of Borga operation in compared to Rajasthan and Indian state and Bangladesh, which shares the same climatic zone as West Bengal. Clear? This paper is almost in the same way. So what happens? The two states almost are adjacent to each other, New Jersey and Pennsylvania. In New Jersey, there was a change in the policy in terms of minimum wage, which has been increased. Pennsylvania didn't do it. Clear? So I want to think of Y1, employment and restaurant I, state S at time T with a high minimum wage. So my 5.05. Y0IST is employment at restaurant I, state S at time T with a low minimum, right? Which is my 4.25. Clear? So note, delta is the treatment effect and DST is nothing but the dummy. So in the absence of minimum wage change, employment is simply determined by the sum of the time invariant state effect. Gamma S is the state effect, lambda T is nothing but the time effect. Clear? Now, if I think of the delta, delta would do what? Delta would be nothing but the difference in the mean, conditional on the state and the time period. Clear? And hence, I then can calculate, this is my observed unemployment. And I basically start substituting each one of the values, employment in February, employment in November, and then I calculate difference between the February and November for New Jersey, where the policy took place. I repeat the same exercise for Pennsylvania, right? And then all I want to do, I have the impact of the policies for Pennsylvania and what? New Jersey. I already took the difference, so that's my first difference. Now I take the second difference, which is New Jersey and Pennsylvania, nothing but estimate my delta, and hence I call it difference in difference. Yeah? Policy effect changes, you don't take into account where it has happened. You know it has happened. West Bengal and Rajasthan. West Bengal has it, Rajasthan did not have it. Right? So I first compare before policy, after policy. West Bengal is my New Jersey. Then I compare Rajasthan. Right? And then now I compare what? Rajasthan in terms of before policy, after policy. Rajasthan does not go through any changes except the fact that the employment can or the productivity can differ because of something else, which is lambda November minus lambda February. There you see lambda November minus lambda February plus delta. So I already take one difference over here. I take another difference over here. I now take this difference here minus this difference, which is nothing but my effect, which can be attributed to the change in the minimum wage. And hence, the method is known as difference in difference. It's not rocket science. Very easy. Clear? Fine.
The challenge lies in identification of the Rajasthan.
I am coming that. I am coming to that. So note, given this framework, I now want to extend this framework in terms of my regression. How do I do it? Look what I have. Overall constant, beta 2 times the post, which the state I, which got exposed to it. Then I have beta 3 times the treat, when the treatment occurs, and then my interaction. What is my interaction? Interaction where the program has taken place times which year or which period it has taken place, plus my random error term, which is EIT. So I am going to be interested in what? I am going to be interested in this coefficient beta 4. Clear? And if I think of the Card and Kruger framework, then that's nothing but my delta. Because you see that you have this, and then you have the interaction. Nj is nothing but a dummy, which is equal to 1 if the observation from Nj. D is a dummy which is equal to 1 if the observation is from November after the policy has changed. And hence, I can think of alpha is my Pennsylvania before policy. Post policy alpha plus lambda. Clear? Because the policy has kicked in. Nj pre is nothing but alpha times gamma because Njs is equal to 1. Right? Then after the policy, it is alpha plus gamma plus this guy lambda because the policy has taken place plus nothing but delta. I now taking the difference. So I first take PA post minus PA pre. That gives me lambda. I now take Nj post minus Nj pre. That gives me lambda plus delta. If I now take this difference minus this difference, that gives me delta. Should be crystal clear. Right? Gamma. What is the interpretation? That nothing but everything else 0. Then you can think of gamma is nothing but if you belong to New Jersey, what would be your outcome? Sorry? Lambda is nothing but, again, pre and the post. Post, it takes the value of 1. Pre, it takes the value of 0. You see that? PA post is alpha plus lambda. PA pre is alpha. So alpha plus lambda minus alpha is equal to lambda, which measures nothing but the impact of the policy which is being captured by lambda in case of Pennsylvania. In case of New Jersey, it would be nothing but alpha plus gamma plus lambda plus delta minus alpha plus gamma. So that's nothing but lambda plus delta. If you now take the difference between the two pre-post changes, that would estimate your policy change, which is delta. Clear? Substitute this value, take 1 and then just do it. It is very easy. Yeah? So what does it happen? I have February, I have November. T is nothing but the time when the policy has taking place. This is my alpha, that portion is my gamma, and then this is lambda. What am I interested in is nothing but the estimate of this guy, which is delta. That's what we do. Clear? So given this, what are the key assumptions? The key assumption for any DID or DD or whatever you call it is the treatment and control group should follow the same trend in the absence of the treatment. Clear? This does not mean that they should have the same mean. They should have the same trend. And what we call it that this is common trend assumption. So what I can then think of that I want to show the common trend assumption, but by using the pre-treatment data. So I want to show before the treatment occurs, you have something like a common trend or a parallel trend. Why it is parallel trend? Because I did not assume they have the same mean. So they can have the same slope but different intercept, which is nothing but the different mean. And that's what the parallel trend in a novice term, and I am a novice guy. Clear? Fine. Okay. So even if pre-trends are the same, one still needs to worry about the other policy changing at the same time. So whether one policy gets, like it's more complicated, that 3, 4, 5 policy has taken place during like 2 years. And you need to identify it in terms of what can I attribute to this policy change or policy change X versus policy change Y. That gets more complicated. Fine? Clear? Okay. One of the way to solve this problem is what we call by, or the solution is by Otter. You can get again the paper. That's the link is there. That which includes both leads and lags in the DD model. So what I do, I do not know, I don't care about this pre and the post, what is happening. So all I want to do, I want to create lag of the policy. I want to create both ways, the lag operator in the backward way, the lag operator in the forward way. So think of you are what you are believing in adaptive versus rational expectation, right? So in a rational expectation, what we do, expectation of xi conditional on it. Recall when it is the information set available to you at time period t, which includes t minus 1, t minus 2, t minus 3 until 0, my lags. Now think of I move forward, xit plus 1. I then conditional that on the same information set it. Or I can update my information set on t plus 1, my forward. Clear? So the way I want to think about it, leads and lags in a DD model, analyzing the effect of increased employment protection on the firm use of temporary help workers. This temporary help workers concept is quite common in lot of developing country. In Spain, sometimes we call them as zero contract worker. In UK, also there exists zero contract worker. You are on the payroll, but you don't have to work. It's zero contract. You don't work, I don't pay you. Clear? Fine. So in the US, employers can usually hire and fire workers at will, anywhere in the developed countries, right? We can be fired. I can be fired anytime. University has to give me 3 months notice. Okay? In academics, it's a little difficult, but they can make your life hell. US labor law allows employment at will, but in some state, courts have allowed a number of exceptions to this doctrine, what we call unjust dismissal. So there will be a lot of court cases. The employment of temporary workers in a state to dummy variables indicate the state court ruling that allow exception to the employment at will doctrine. The standard thing to do is normalize the adoption year to 0. And Otter, what they did, or what he did, is basically start looking at -2, -1, 0, 1, 2, 3. And that's what my next slide would give you in terms of the models. Okay? You will see minus tau is equal to minus q to -1. Then the tau starts running from 0 to m. Treatment occurs in year 0. Q leads anticipatory effect, right? What could happen? And then M leads is nothing but the post-treatment effect. Clear? Fine? And the way, this is the way, I recall that paper pretty well. So I remember 2 years and 1 year. So that is like the 2 years prior, what has happened? 1 year prior, what has happened? Then this is the year of adoption. Then 1 year after, 2 years after, 3 years, 4 or more years after. Remember your tutorial? We stop the export duration at year 5. Generally, the effect gets stabilized or we don't bother that much. Right? So the way you want to think about it, time passage relative to the adoption of implied contract exception, and the way to do it, or Otter did, 2 period before, period when it happens, and then period after, 1 year, 2 year, 3 year, 4 years. Clear? Fine? Yes. Yeah.
So this example of
Yeah.
Otter means just that instead earlier we had only 2 time period, before and after.
You have multiple time
Here
period.
we are having
Multiple time
more than
period.
2 time periods.
Multiple time periods. You are right. So one of the problem, I'll just finish this slide and then take the break. One of the problem is, how do I control for the standard error? Or the standard error would not be estimated properly. easiest solution to do it something like there are one way to do it is do the block bootstrapping standard error. You can do clustered standard error. So one way you can think of that the outcome variables are serially correlated. Hence, I need to do clustered standard error, right? I may want to think of that conventional standard error severely underestimate, and hence I want to do block bootstrapping standard error or clustering standard error. Anything you can do in Stata in terms of either the block or the clustered standard error, and clustering can be at the individual level, can be at the unit, I mean, what the individual belongs to, which is the state or district or sampling unit, whatever you want to do. Clear? So that's the way you want to think about it, right? So note here the serial correlation we are talking about is in terms of group level, which is state, and the outcome variables are often serially correlated, right? And the other way I think about it, it is the correlation can occur not over the time period but across unit. You see, you have shared your laptop screen with her. So at the same time, there is a spatial effect over here. Why? Because from your screen, she could see the output of regression on wage on training and with or without control. So there is a learning in terms of negative to positive coefficient, and that's nothing but the spatial effect. When it is your machine, this is your direct effect, and this is nothing but indirect effect. And that's what I do nowadays a lot, and that's why I want to talk to you. Okay. So in terms of the sustainability. Clear? Fine. Shall I take a break? It's what time? 11:45. Sorry, I ran out. It started at 12. मेगा क्या हुआ डेटा का? क्या कर रहा है? Sorry?